Hello friends, welcome back to our channel. Today we'll see one more important concept in machine learning, that is a performance classifiers. So in our previous session we have discussed about a different classification models, right? So which will be predicting the output or a class, right? So here the question is, how far the classifier model was working correctly. So in order to evaluate the performance of the classification model, there are different metrics, and these metrics will be using to calculate the performance of any classification model. So performance classifiers are the metrics used to evaluate performance of any classification model. So how far the classification model was working correctly, right? So we have seen different examples also. So here what are the metrics? The first one is a confusion matrix. Next, accuracy. Precision. Recall. Specificity. F1 score. Error rate. So these are all different metrics which are being used for evaluating any classification model. So here, coming to this confusion matrix, so by using this confusion matrix, there will be four possible outcomes. So four possible outcomes. So we'll see one by one. We'll see one by one, right? So first, let us move on with the confusion matrix. Coming to this confusion matrix, there will be four possible outcomes. One is TP, which stands for true positive. So what it means positive instance correctly classified as a positive. So for example, if you consider one model to predict the disease for a person, if a person is having the disease and the model was also predicted that the particular person is having the disease, that comes under this true positive. Similarly, TN stands for true negative. True negative. So that means the negative instance correctly classified as negative. Correctly classified as a negative. For example, if a person doesn't have any disease and the model also predicted that a person doesn't have any disease and he or she is healthy, that comes under this true negative. True positive and true negative. These are actual positive and actual negative. So prediction was correct. And now false positive. So this is a false positive. This is negative instance incorrectly classified as positive. Classified as positive. That means if a person doesn't have any disease, right, and the model predicts wrong, that means having the disease, that's a false positive. Similarly, false negative, FN, it's a false negative. So here, positive instance, incorrectly classified as a negative. Positive instance, if a person is healthy but the model predicts that person is having some disease, so that is a false positive. So the confusion matrix will be having the 4 different outcomes: true positive, true negative, false positive and false negative. So these 2 are correctly predicted and these 2 are wrongly predicted. Okay, the negative instance prediction as a positive, and here the positive instance predicted as a negative. So this is the first one, confusion matrix. And the second metric, so remember these 4 terms, so which is a true positive and false positive, false negative and true negative. Okay, these are the 4 different terms, and based upon these terms we will be measuring the different metrics. Okay, so the next metric is an accuracy. Accuracy means the percentage of correct predictions. So there are 4 possibilities for classification. These are the 4 possibilities of classification. Among these 4, the percentage of correct predictions. What are the correct predictions? So these 2 are the correct predictions. These 2 are the correct predictions and these are the false predictions. So the accuracy formula will be, the accuracy is equal to true positive plus true negative divided by all the instances, true positive plus true negative plus false positive plus false negative. So this is a percentage of correct predictions, and the next one, the next metric is a precision. So here, out of all positive predictions, how many are classified as positive? Sorry, how many are actually positive? How many are actually positive? So out of all positive predictions, that means, see, a precision P is equal to how many among all positive predictions. What are the positive predictions? TP and FP. TP plus FP, both are positive. So true positive and false positive. So how many are actually positive? Actually positive means true positive. So this is a formula to find out the precision. So out of all positive predictions, how many are actually positive? Next, the next metric, recall. So out of all actually positive predictions, how many are classified or identified correctly? That means actually positive predictions. So what are the actually positive predictions here? One is a true positive, and also the false negative is also the prediction. The actual positive, false negative is also a positive. So among all these actual positive predictions, what are the I mean, how many are identified correctly? That means correct predictions, TP. Okay, the percentage of actual positive predictions. So this is a formula for recall. And the next one, specificity. Here, out of all actually negative predictions, how out of all actually negative predictions, how many are identified correctly as a negative? So here it is a positive. Here it is a positive, but here we are just finding out of the percentage of negative predictions. So here the specificity is equal to what are the actual negative predictions. So total negative plus false positive. This is also actually negative, but it was predicting positive, right? So this is a formula for specificity. Okay, so out of all actually negative predictions means this is actually negative, true negative, and also false positive. So actually it is negative, but it was predicting positive. So it will be considered these two also. Out of all these things, how many are identified correctly as a negative? That means a true negative. Next, so balancing this recall and precision, there is a one more metric called F1-Score. F1-Score. In order to balance precision and recall. So for the formula, F1-Score is equal to 2 into precision into recall divided by precision plus recall. So this balances both the precision and recall. These are one more matrix. And the next one, error rate. Error rate is nothing but 1 minus accuracy. Okay, so that means finding out the percentage of incorrect predictions. Incorrect predictions. So error rate is equal to how much? Incorrect predictions. Incorrect predictions means false negative plus false positive. Both are incorrect, right? Both are incorrect. Divided by true positive, true negative, false positive, and false negative. So this is the error rate, which is the percentage of incorrect predictions, and also we can say 1 minus accuracy. 1 minus accuracy. And one important point about these metrics is, so not a single accuracy doesn't give the performance of a working classified model. It doesn't sufficient. Okay, so we need to calculate all these things like accuracy, whatever we've seen. Next, precision and recall, F1-Score, error rate, specificity. So all these metrics are very important to find out the performance of any classification model. So depends upon the application, we need to consider which we have to do, right? So these are the different performance classifiers. That means the metrics to calculate the performance of any classification model. So in our previous sessions we have seen the classification models which will be predicting the class of that particular data. So how far the selected classification model works well will be evaluated based upon these particular metrics, right? So I'll stop here and hope you understood this one, and if you enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.